This video is from Chapter 7, Section 4. We're looking at objective number 1, which is solving problems involving geometry. I'm going to do example number 1 from page 403 in our textbook. This is an application problem or a word problem, and what you want to do is make sure that you've read it carefully. So we start out and say a rectangular vegetable garden is 7 feet longer than it is wide. What are the dimensions of the garden if it covers 60 square feet? Okay, I read it, but now I kind of need to read it again because I need to look for clues or information that I'm going to use. So first of all, I'm going to read it and let's see, a rectangular vegetable garden. I think this is important, not vegetable garden, is 7 feet longer than it is wide. That's important. When I see what are, I know that that's what they're looking for, of the garden if it covers 60 square feet. So with this, just reading through it, I've learned a lot. I know that, for instance, this is an important fact. This is a really important fact. And this is an important fact. I've also figured out what they want. They are looking for the dimensions of the rectangle. So I have some good things to start with. The next thing I like to do is make sure I know what all the words mean, and in this case I'm pretty good. Rectangular might give me some trouble. Dimensions are the measurements around. And so what I want to do right now is draw a picture. So here is a rectangle. Okay. Now, we know that the rectangle has a dimension that's width, and it also has a dimension that's length. We just know that. That's part of our background knowledge. We also know that area equals length times width. That's background knowledge. So let's go back up here and take a look at the problem to get some more information. We took care of the rectangular, 7 feet longer than it is wide. One of the things I always kind of look at is the word than. So here's than it is wide. That to me tells me that we're really going to use this as our variable. We're going to start with W, and then we'll have W 7 feet longer, W plus 7. So that gives me my important little thing. And we know that the area is 60. They didn't just say that the area was 60, they said it covers 60 square feet, which is kind of like a tablecloth or a bedspread would cover. So we've got enough to get going, so this is good. So we know that 60 is the area, and the length is really W plus 7, right? And then the width is still the width. So we're going to solve this. First we're going to distribute W squared plus 7W. Now this is getting close, but to do this right, I need to have it set up as a quadratic. So that's ax squared plus bx plus c equals 0. That's the form I'm looking for that I need to match, and that's really a 0, not a bleh. So to make this look more like this, I need to make this side 0. So I'm going to subtract 60 from both sides. So now I have 0 equals W squared plus 7W minus 60. And that is my quadratic, and I'm good to start with this. What I would like you to do right now is stop and copy. And I will meet you on the next slide. Here we are again. And we're setting up with W squared plus 7W minus 60 equals 0. Now my job right now is to find the values of W, and to do that I can break this up into two factors. Of chunk times a chunk equals 0. Now, many of you are probably excellent at looking at an equation like this and being able to just pick out the factors by intuition. I unfortunately am not very good at that, so I'm going to do it the long way. The coefficient here is 1 and C is negative 60. So 1 times negative 60 is negative 60. Okay? I need to find factors of this that if I combine them, they will give me positive 7. Because this is negative, I know that one of my factors will be positive and one will be negative. I don't know which one yet. We'll see. Oops. We'll see. Really, we will. We'll see. Okay, let's be systematic about this. You can bump around and guess all you want, but let's be systematic. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, and I think we're good. After that, it'll start to cycle around again. So one of these is positive and one of these is negative, so I'm going to combine them. I'm going to subtract and find the difference. So 60 minus 1, it's not that. 30 minus 2, it's not that. 20, nope. 15 minus 4 would be 11. I'm getting close. 12 minus 5 is 7, and 6 minus. So I'm looking for positive 7, so it's this one. Now, this is positive up here, so my larger number will be the positive and my smaller number will be the negative. So I'm going to end up with W plus 12 times W minus 5. One of these has to be 0 to make this true. So let's set this up. W plus 12 equals 0. W equals negative 12. If W equals negative 12, then we'll end up with negative 12 plus 12 times negative 12 minus 5 equals 0. 0 times negative 17 equals 0. That's true. Now, you don't have to do this for every single time, but I wanted you to see why it worked. So up here, let's come back up here. W minus 5 equals 0. W equals 5. So after all that, I have two choices. W either equals negative 12 or W equals 5. And here we have to test for reasonableness. Does this answer make sense? And remember, we're dealing with a vegetable garden in the real world with carrots and radishes. Can you have a measurement on a fence that is negative 12? Well, no, you can't. You can only have a positive number if you're dealing with this. So we're not going to use that one. We're going to use this one. So W equals 5 and length equals W plus 7. So length equals 5 plus 7 equals 12. Remember, they were looking for the dimensions, so the width equals 5. Don't forget the units. And the length equals 12 feet. Oops, not felt, feet. Feet. So again, you are going to stop and copy. And when you're done copying, I would like you to go to You Try on page 403 and do that in your packet as well. And that's the end of our first video.